Hello everyone, and welcome to the MAT 211 review on linear systems of systems of linear equations. Hello everyone, and welcome to the MAT 211 review on systems of linear equations. My name is Julia, and I work for the tutoring centers at ASU. So for our example problem, we want to solve the following system algebraically. So we want to express our answer as an ordered pair that would be x, y. If there's no solution, we want to enter no solution. And if the system is dependent, we want to express our answer in terms of x, where y equals x, or y of x, excuse me. So what this means is that y is some function of x. So it's in terms of x. So it could be like x squared plus 2 or, 3 over 4x, something like that. So we want to make sure that we're showing all of our work as well. So we have these two equations. We have 2x plus y equals 10. And we also have x plus 3y equals 20. And we want to see if there's a common set of solutions that work for both of these equations. So with any system of equations, there are three possibilities for our solution. We could have no solution. Excuse me, my handwriting is terrible. And this occurs when the graphs of each equation do not intersect. So that would be something like where they're parallel. So if we had, a line going here and then another line going here, and they never intersect because they have the same slope. So another possible solution is when we have one solution. And that occurs when we have systems or equations that intersect at one point. So you'd have something that goes like that, and maybe another one that goes like this, and they hit at exactly one point. So a third possible solution space is when we have dependent solutions or infinite solutions. And that occurs when we have two equations that run exactly along each other. So they're right on top of each other. So pretend there's two lines there. And so at any xy point, they're going to have the same point in space. So any xy point that falls within one line also falls within the other line. So for our example, we have these two equations. And so there's a couple different ways that we could go about to find what sort of solution that we have. One of these methods is substitution. So substitution is done by solving for one of the variables in one of the equations and then substituting this solution in the other equation. So let's see how this works. So let's take our first equation here, 2x plus y equals 10, and we're going to solve for it in terms of y. So if we have 2x plus y equals 10, well, we can just subtract 2x from both sides. And this gives us, so these cancel out, and we have y equals 10 minus 2x. So now that we know that y is equal to 10 equals 2, or 10 minus 2x, then we can substitute this solution or this definition into our other equation. So let's do that. So we have x plus 3, and then so instead of this y here, we're just going to just substitute in, dang it. Hello everyone, and welcome to the Mat 211 review on systems of linear equations. My name is Julia, and I worked for the tutoring centers at ASU. So for our example problem, we want to solve the following system algebraically. And we want to express our answer as an ordered pair, x, y. If there's no solution, we're going to enter no solution, or we're going to write down no solution. If the system is dependent, we're going to express our answer in terms of x, where y equals y, some function of x. So y equals y of x. So this could be something like where we have like y equals 1/2 x plus 2, or some other form like that, but everything on this side will be in terms of x or just, you know, a lone coefficient. So, and we want to make sure that we're going to show all of our work for this. So we have these two equations in our system. We have 2x plus y equals 10, and we have x plus 3y equals 20. So there are 3 different possibilities for solutions for any system of equations. We could have no solution, and this occurs when the graphs of each equation do not intersect. So for instance, if we had a graph, we would have 2 functions or 2 equations, one that's like this and one that's in some other space like this. So they're always running parallel to each other and they never intersect. So another possibility for our solutions is if we have one solution. And this occurs when we have 2 equations that intersect at one point. So you might have one that goes like this and another one that goes like that. And then we have this one point in the center where they intersect. So now a third possibility is when we have dependent solutions. And so like this guy here. And what that means is that all the equations coincide with each other at all points. So for any XY pair in one equation, it's also going to be in the other equation. So that happens when we have equations that are multiples of each other or basically represent the same line in space. So they'll be right on top of each other. So if we look at our example, there's a couple different methods that we could use to solve this linear system and figure out what pairs of x, y values work for both of these. One of those methods is substitution, which is done by solving for one of the variables in one equation and then using this solution for that variable and substituting it into the other equation. This allows us to get rid of, in one of the equations, one of the variables. And so that way we can solve for the other variable. So for instance, in our case, we're going to have, let's start with 2x plus y equals 10, and we're going to solve for y. So if we have 2x plus y equals 10, if we subtract 2x from both sides, this gives us y equals 10 minus 2x. So this is a definition of y in terms of x. And we can substitute this in to our other equation for the y here. And that way we only have this equation in terms of x's. So let's do that. So we have x plus 3. And now instead of writing y here, we're going to write 10 minus 2x. So that's 10 minus 2x. And then that all equals 20. So in order to solve this for x, we first want to distribute our 3 across. So we're going to have x plus 3 times 10, which is 30. And then we have 3 times negative 2x, which is minus 6x, and that all still equals 20. So we can simplify this some more by subtracting 30 from both sides. And then this guy cancels out, and we have x minus 6x equals negative 10. So 20 minus 30 is negative 10. And then we can also combine these two x terms. So x minus 6x is negative 5x equals negative 10. Now, lastly, we just have to divide both sides by negative 5 because we want to get this x by itself. And so we have these two cancel out, and we have x equals negative 10 divided by negative 5. Negative 10 divided by negative 5 is 2. So we have x equals 2. So now what we want to do is we want to substitute this x equals 2 into one of these two equations in order to solve for, hopefully, for a value of y that allows us to find one specific point. So if we get one specific value of y, then we know we have a specific point. So let's substitute this into our top equation again. And you can do it in either, so feel free to check with the bottom one too to make sure that this works. So we have 2, and so instead of our x here, we're going to substitute in our 2 from here. So 2 times 2 plus y equals 10. So that gives us 2 times 2 is 4 plus y equals 10. And then we can subtract 4 from both sides to get our y alone. And that gives us y equals 10 minus 4 is 6. So y equals 6. So now we know that we have an ordered pair, which is x, y equals 2, 6. And that ordered pair is the point of intersection in between these two equations. Let's clean those up so we can see them again. So you can check to make sure that your work is correct by just substituting in your 2 and your 6 into each of these equations and making sure that the resulting value is equal to 10. So let's do this for the first one. So we have 2 times 2 for our x plus 6 for our y equals 10. And of course this holds true. So this is 4 plus 6 equals 10 equals 10. This checks out. We can also do this for the bottom one. So we have x, which is again 2, plus 3y, so 3 times 6 equals 20. So that gives us 2 plus 18 equals 20. And we know this to be true. This is going to be 20 equals 20. So that checks out as well. And so our ordered pair here is, for our single solution, is 2 and 6. So last thing we want to talk to you about, or I want to talk to you about, let me see if I can get this to go to the next page. There we go. Nope. Come on. There we go. All right, let me clear my annotations here for you so you can read this. All right. There we go. Hello everyone, and welcome to the Mat 211 review on systems of linear equations. My name is Julia, and I work for the tutoring centers at ASU. For our example problem, we want to solve the following systems algebraically. We want to express our answer as an ordered pair, x, y. If there's no solution, we want to enter no solution, or if the system is dependent, we want to express our answer in terms of x, where y equals some function of x, so y of x. And we want to show all of our work, of course. So we have these two equations, 2x plus y equals 10, and x plus 3y equals 20. So for any system of equations, there are three possibilities for solutions. We could have no solution, and this occurs when the graphs of each equation do not intersect. So for example, if we graphed equations that had no solution, we would see that they run parallel to each other. So they're always the same distance apart and they never intersect. Alternatively, we could also have one solution. And in the case where we have one solution, we have two equations that intersect at a single point. So they have different slopes, one points in one direction and one points in another, so they intersect at a single point. And that single point would be our XY pair. Our third possibility is that if we have dependent solutions, which also means infinite solutions. And this is true when any ordered XY pair that satisfies one of the equations also satisfies the other equation. So this happens when we have two equations that actually run right on top of each other. So they might be multiples of each other. So in our problem, there's a couple different ways that we could approach finding out what sort of solution we have. One of these methods is substitution. And in this method, we solve for one of the variables in one of the equations, and we substitute that solution for the variable into the other equation. So for example, we could solve for y in our top equation, and we'd have some solution for y in terms of x, and we could substitute that solution for y in terms of x into the y in our bottom equation. So let's do that. So we have, for our top equation, we'll start there, we have 2x plus y equals 10. So let's go ahead and solve for y. So that means that we're going to subtract 2x from both sides. These guys are going to cancel out. And we have y equals 10 minus 2x. So this means that we have a definition for y in terms of some statement involving x. And so there's no y's on this side. And so what we can then do is take this definition for y in terms of x and substitute it for this y in our second equation. So that gives us x plus 3 times, now we're going to write, instead of y here, we're going to write this definition. That gives us 10 minus 2x, and that all still equals 20. So in order to solve this in terms of x, we first want to distribute our 3 across our 10 minus 2x. So we're going to go, we'll have an x plus 3 times 10, and that's 60, plus, or minus, in this case, 3 times 2x, so minus 6x. Oops, that I wrote. That's not supposed to be, it's supposed to be a 30. And that's still going to equal 20. So now we can subtract 30 from both sides. So minus 30, minus 30. And that gives us x minus 6x equals negative 10. So 20 minus 30 is negative 10. And then we can combine these two. So x minus 6x is negative 5x equals negative 10. And lastly, we'll divide both sides by negative 5. And that gives us x, because these two cancel out, equals negative 10 divided by negative 5, which is 2. So there we have our solution for x. Now we can take this solution for x and we can substitute it into either equation in order to solve for y. So let's use our top equation. We have 2, and we would have x here, but we're going to substitute our 2 in for x. So 2 times 2 plus y equals 10. And so this would be 4 plus y equals 10. We're going to subtract a 4 from both sides. And that gives us y equals 10 minus 4 is 6. So our ordered pair here is x, y equals negative 2, or excuse me, 2, not negative 2, 2, and then y equals 6, so 6. So this means that we have one solution to these two equations here. We can double check this real quick, make sure that we did our calculations correctly, because the 2 and the 6, when substituted into either of these equations, should balance out so that we have this side will equal 10 in this case, and this side will equal 20 in this case. So let's go ahead and just check that real quick. So we have 2 for the top one times 2 for our x plus 6 for our y equals 10. And that's going to be 4 plus 6 equals 10. We know that that is 10 equals 10. So our top equation checks out. For our bottom equation, we have 2 for our x plus 3 times 6 for our y equals 20. And that's going to be 2 plus 18, 3 times 6, equals 20. And 2 plus 18, of course, equals 20. 20 equals 20. That checks out as well. So, last thing I wanted to tell you about was, let me advance this to the next slide, and we'll clear this guy. I wanted to give you a reminder that if you are looking for additional tutoring services or academic support services at ASU, please visit the Tutoring Center website, tutoring.asu.edu, and use the tutor search function to find tutoring services for your course. So this link right here will take you directly to that tool. So thanks so much and have a great day.